Like Matt said, my name is Ian. A little bit about my background. I have a bachelor's of science in film and video production. I worked as an audio engineer for the NFL for a couple of years, and then decided to come here to Galvanize. I wanted to, I've learned so much about full-stack web development these last 6 months, and I wanted to find a way to blend some of my knowledge with full-stack web development in general, with some of my skill sets in film and video production. And I take the BART here every day on the way to school, and one day it came to me to try to do some sort of 3D rendering of a cityscape. So looking up at the buildings and all that stuff, it just kind of came to me, and it's been a journey learning this new technology. This is not something that we actually learn in the program. This is a library I use called Three.js. Three.js sits on top of WebGL, which is the web standard for rendering 3D graphics in the browser. And so the way I had actually rendered this city, it's 100% procedural. What this means is that rather than using a program like Unity, or there are other 3D rendering programs out there, I decided to let the code work for me. So I wrote a program that would generate the city with the raw materials from the library. And the city is essentially broken into boroughs. Boroughs are broken into blocks, and blocks have a cluster of various shapes of buildings. As far as lighting is concerned, the way Three.js works is you have a scene. That scene gets rendered in an animation loop. And so that animation loop runs at about 60 frames per second. And the lighting that I added to this scene, 4 spotlights, one on each corner of the city. And with the spotlights, you can control things like, how does the light decay? Is it a linear decay? Is it exponential? Is it a natural decay? And things such as direction and color. At the bottom of the city here, you can see I have this is called a point light. Point lights actually, they emit light in all directions. So I actually use that to light up the city from the bottom. This is the center borough there. And then here at the top, I actually used another point light and added a lens flare effect in post-processing. And so that kind of gives the illusion of an actual camera in the 3D renderer. So as far as the way the buildings are constructed, you select your geometry and you select the material. And those combined create the 3D object. And so a big challenge early on was I was only able to actually render 150 buildings. Here I have actually 38,000 buildings, and the way I was able to render this many buildings was to merge a lot of these geometries. You could think of each building as an object in JavaScript, and to reduce that memory footprint, you essentially merge them into a single object. So each borough in this city is a single object of memory. And that's how I was able to render as many buildings as we have here. You probably noticed the star field. This is actually, in Three.js, you can take a geometry, you can take its vertices and convert that vertice into some sort of texture. So this is actually 3 dodecahedra. I learned a lot about geometry these last 2.5 weeks. A dodecahedron is a 12-sided polygon. So I took 3 of those, and I offset each one by rotating it some factor of pi radians, and then converted each particle to a tiny HTML canvas. Let's see if I can get a good view for you guys. And so essentially, each one is a small HTML canvas with a radial gradient. And I animate that gradient. And so it has a flicker effect of sorts. As far as other lights, there was this hemisphere light. This adds a little more color and light to the scene. One of my favorite features about this project was to actually play with the audio API. It's in the browser. And I could analyze waveforms from a song. With that data, I created an average value, and then with that value, created a color. With that color, I generated a palette, and that palette would make up the lights of the city. So, because this is running at 60 frames per second, the lights would go to the music. So I'll show you guys kind of what that looks like. Taste of my interaction with the audio API, and I had a lot of fun learning this. Definitely was something that was completely new, and I had to pick up a book on Three.js because it is a technology that's actually in alpha, meaning it's not even beta, so it's changing all the time. And it's definitely had a lot of challenges, but overall, the potential for something like this, you can go into VR and AR with this sort of technology. So definitely plan on doing a lot of that in the future. Thank
you. Thank you, Ian. This is very impressive. And all of your projects have been really impressive. You are using some technologies that you didn't learn at Galvanize. So can you say a little bit more about your process of researching them and making decisions and then learning about them and doing a lot with a small amount of time?
Yeah, definitely. So I did a lot of research early on to see what the best way to get started with 3D rendering is, especially in the web browser. And Three.js is a library that sits on top of WebGL. WebGL is a very powerful technology, but it's very difficult to work with. There's a lot of lower level things that happen that you have to be able to manage. Three.js allowed me to work with things like geometries and generate code that's more object oriented, which lended itself well to my project. I definitely, with a film background, I was able to kind of come up with a lot of mock-ups as far as sketching what I would like the city to look like, lighting models. I did a height map. Everything was analog first, so just pencil and paper. And it was a constant struggle of adding features and seeing, well, this really slows down my render loop. Maybe I shouldn't add that. The merging of geometries definitely was a thing I had to pick up along the way. But overall, I think that it's just been me exploring this technology and seeing what I can come up with.
Yeah, I'm curious to hear about, you talked about the memory footprint issue.
Right.
I'd like to hear about your process of working through that and kind of, when you hit that wall, what did you do? Did you think the project was done? How did you even begin to debug that?
So I think to handle the memory footprint issue, I had to do a lot of research, a lot of Stack Overflow, and the book I did read did have some information about how to reduce that memory footprint. I think getting started, you have a tendency to just create everything as a separate object, a separate entity, and that's great, but then when things scale, thankfully I had this statistical analysis up here for the frames per second, and that allowed me to see kind of what worked and what didn't work through trial and error. As far as merging the geometries, that I'd say it has to do a lot with, I had to decide early on what was going to be moving in the scene, what was going to be animated, because when you do merge things, they tend to be, one body. So it becomes difficult to change, a single face of a geometry or a single vertice. And so working through that was definitely a challenge.
You may have just matched Elon Musk's Mars mission demo, and it was just incredible. How do you do something like that? I mean, how did it start? Can you take us through the process when did you have the vision of creating something like this, or was it the process, can you just from the scratching and coming up with the idea to this?
Right.
How was the process?
So the process, I spend a lot of time on CodePen. CodePen is a website for front-end developers. And I've seen a lot of 3D renderings done. And so I wanted to, I've always been interested in exploring a lot of things with 3D rendering. As far as the actual figuring out how I wanted to go about this and what I wanted it to look like, I researched a lot online as to what cityscapes generally look like, how they're formed. And, Tron Legacy was actually a big part of this project. I really liked the way Tron looked. A lot of the aesthetics that they used, I tried to implement into my own project. But I did notice a lot of projects that did involve cities, they were trying to do something like Grand Theft Auto, where they were trying their best to model a realistic city. And I felt like if I was to go more of an abstract direction, I could do a little bit more and make it more of my own.
So just last thing here is, this is what you started? Like, you hit something that you wanted to do at the end?
Yes, I think when I started I didn't have exactly this, I knew it was going to be abstract. I didn't know exactly what was possible. I had a lot of trial and error, adding, for example, little particles as lights on each building. That was actually meant to be part of this project, but because of this memory footprint issue, I had to come up with different ways of making things. So, I added some reflective material to kind of reflect the light instead.
Super.
You talked about the city being procedurally generated. Did you experiment with randomness? Is there randomness in this, or is it more like you picked numbers that gave you the aesthetic that you liked?
I definitely did play around with what kind of worked and didn't work, as far as everything is randomly clustered into a block. So each building, every time a building is created, it's either some form of a cone geometry or of a rectangular prism geometry. And so as far as like the number of sides of each geometry, that is random. The height map that I generated, that essentially sets kind of a min-max as far as the smallest a building should be, given the borough or the block, and then the largest it should be. And so that allowed me to kind of give a range and lay out the city so that everything kind of would generate the way I wanted it to be.
Kind of feel organic.
Right.
You mentioned pushing up against some of the technical limitations of rendering in the browser and trying to do that intelligently. How close to pushing the envelope of that are you? Did you scale way back and you're like, let's make sure this runs really smooth? Or are you just under that ceiling of what you can do?
Up here you probably can't see it from where you are, but it says 60 frames per second. So as long as you're within around 45 to 60 frames per second, you're able to kind of get things moving. And the human eye really won't know the difference. But as far as where I am, I definitely can add more. I think that if I was to move forward, there are a lot of lower level optimization tricks. Particularly there's a language called GLSL, which is a C-like language that sends commands directly to the GPU. And so people who are very, very serious about whether it's game development or any sort of 3D rendering, that is kind of the next the next step, because you can do so much with that skill set.